So, hi everyone. I'm Phillip Cloud. I work at Continuum Analytics, working on Blaze, Odo, and a couple of other open source libraries, as well as doing a little bit of consulting. So first I'm going to sort of give a quick overview of Blaze and how that works. And then I'm going to sort of jump into a problem where I'm going to figure out which New York City boroughs you want to avoid because the taxi drivers drive too fast. All right. All right, so I'm going to start with a quick poll. Who uses like raw NumPy, just like base NumPy? Okay. So that's like most people. Who uses pandas? Like, okay. Also most people. Cool. So Blaze is sort of designed around the interface of both these things and designed to handle systems that don't fit into the abstractions that NumPy and pandas provide. So it's a lightweight interface on top of like things that already exist. So if you have a database, Blaze can work with that. If you have a data frame, Blaze can work with that. If you have a CSV file, Blaze can work with that. So a couple of imports. You guys see this in the back? Is this big enough?
Pretty small.
Other stuff? Okay. Is that better? Okay. Bigger? Eventually things are going to start doing that and get cut off later. But I'll sort of adjust as I go. We can also sort of operate on sort of like objects that have a table-like structure. So if you have a list of tuples, we can work with that. And the way, roughly speaking, the way Blaze works is that you create a symbol that's an expression, and then you build up an expression tree as you go. And we'll go through some examples of that. And they let you build up, they let you write code that feels sort of like NumPy and pandas, but can run code on sort of a system, can execute code against your data where it lives rather than having to bring it somewhere, do your stuff, and then send it back. So let's start with something really simple, lists, right? We can give Blaze a list, and it sort of happily lets you do kind of computations with it. Oh, I forgot to actually run the notebook. Can't see any output. Okay, is that gonna work? Maybe? No, okay. Sorry. Okay, that's not working. Ah, okay. You can tell I don't really use the slides feature that often. Okay. All right, there we go. Blaze uses pandas for pretty printing because has anyone ever looked at the pandas printing code? Oh, I'm sorry. It's fun. Okay. All right. So we can sort of write these expressions, do whatever we want with them, and it sort of feels like standard kind of NumPy and pandas. And we can operate on. So the thing I was showing you here is just like basically a vector, right? It's a symbol list, and then, but we can operate on a list of lists or sort of anything that looks like a table. This little thing that's showing you the time is a little IPython extension that I wrote that it's called auto time, and anytime you run anything, it will just spit out the time that it took to run. Okay, and so we can do aggregations, we can do sort of column access, and there's the underlying thing that's driving sort of the operations and describing the data layout is something called data shape, which is a type system that combines the shape of a particular piece of data. So in this case, I have 5 rows, And then I have a sort of struct-like thing, which we call a record, with these fields and with these particular types. So here's X again. This is what it looks like. Everything kind of looks like pandas because, of course, we use their printing. Let's say we want to know who has a negative balance, the deadbeats. So you can sort of do it as if you were operating like with pandas directly. This may not seem that interesting because it's like, okay, why don't I just use pandas? Where it becomes interesting is when you start generating like more complicated like SQL queries that have lots of filtering and joining and so forth. And I'll show a couple of examples of that in the taxi trip dataset exploration. So that was driving a list of lists. This we can sort of just drive pandas as well, and our code basically looks exactly the same. This is getting cut off. So I'm doing the same exact thing that I was doing before with the list of lists. The outputs of every Blaze operation are Blaze expressions. So if we look at the type of deadbeats, it's a field, and the reason is because I'm saying .name right here. It's a field access. If you look at the child of that expression, it's a selection, which is a filter. But if you actually want to get out something concrete, you call compute. Okay, so I say compute on deadbeats, and that runs the expression against whatever backend is bound to the data object.
Make it bigger.
Bigger? Sure. Good? So if we look at the type of the result of compute, a type of that is a pandas series. So in general, when you input something from a particular ecosystem, like a pandas thing or a pure Python thing or a SQL Alchemy thing, you're going to get back a thing from that same ecosystem. So I input a pandas data frame, I get a series out. I input a NumPy rec array, I get a NumPy array out. We can work with various other things, like I've already mentioned, Python and pandas. We can also work with SQL Alchemy tables. So here I'm constructing a table that's not really bound. It's not bound to a database. It's just a table with a name and a couple of columns and their types. So I can say I can look at the data shape. I can look at the table. And again, we follow this sort of principle that you get a thing of like type X in, and you're going to get a thing of type X out. So here when you call compute on something that's bound to a SQL Alchemy thing, you get back a select object. And because those things have some nice printing mechanism built in, you can actually look at the SQL that's generated. Modulo the bound parameters. But you can also look at those too. We'll see that later. So let's actually connect to something real. Here I'm connecting to the Iris, a SQLite database that's holding the Iris data set. One thing that's nice about Blaze is that it allows you to sort of explore structures that aren't necessarily tabular. So for example, here I've made a data object out of the entire database. So I can sort of drill down and look at tables and explore what's there with their data shape. And I don't have to, so if you were to do this with SQL Alchemy, right, you would have to create a metadata, you would have to stick the engine in there, you'd have to look at all the tables, and then you would have to sort of discover all the types. Blaze does all that stuff for you, which makes it a lot easier to inspect your data. So the fields of the database are tables, and then I can sort of, just like I showed before, we just have an extra sort of level in the expression tree that has all the tables. And we can do more interesting things like a group by. Here we're grouping by the species and getting the min and max sepal length for each species. And of course we can look at that by calling print on the result of compute. And there's an underlying library that Blaze uses to describe how to access data, and that's with these URIs, and that's part of Odo, which I'll talk a little bit about later. So that's sort of the intro, the end of the intro. Does anyone have any questions so far? Yeah.
So in the SQL example, it seems like the idea that you can kind of do, you could do all that relational algebra stuff in memory with pandas, but you might want to do it in the database, but you might want to use pandas like syntax. Is that kind of the idea? It's like you can sort of write pandas and then it will figure out the SQL and do it in the database?
Right. So the example that I really wanted to show, but I ended up using a different database because I didn't want to depend on the Wi-Fi, is like driving a Redshift instance with this stuff, which is, you know, wherever it is, and then I can interact with the remote thing as if it were here on my machine, which is kind of nice because I don't really have to think about like sending the SQL over, like getting the result back as like whatever it is, parsing it. I just sort of say, hey, like SQL Alchemy, like send this query over, and then the underlying sort of DB API handles that stuff for me. So interacting with things sort of where they are rather than bringing them to you is the main idea here. Yeah.
You're not loading the whole database into memory.
Not at all.
So essentially, when they do this execute or evaluate or whatever, then it goes in and query and
Yeah.
load it into memory.
Yeah, so you could get back a result from the database that just won't fit in memory. But there's a few ways you can get around that. We have there's some streaming stuff that's sort of in the works at the moment. But yeah, wherever, if you're using a SQL database, it's going to execute in that SQL database natively. It won't ever bring things into memory, then do your relational algebra. Any other questions? Yeah.
So are there any operations that are blamed operations that are dependent on which backend you're using? Or are all, like, is there something where you write it and it would be connected to SQLite and then you switch to Redshift and it wouldn't work anymore because it's up to different backend?
I'm sure there are. I can't think of any off the top of my head. One sort of thing that we're discussing and talking about is if we want to go down the route of going like deep down in a particular backend and sort of saying like, hey, like this backend isn't going to give you what you want, but there's these other backends that have various sort of, for example, like time series operations in databases are fairly hard to express uniformly across all of them. Like for example, like generating a list of numbers in MySQL is like really hard. There's various like ways and things that they don't implement that don't allow you to do that kind of thing, where you maybe want to like generate a date range and implement resample or something like that. And Postgres has like a generate sequence function, but like you can't even generate a list of numbers in MySQL. So those kinds of problems make it difficult to even go like in one backend and sort of abstract everything away. So it sort of depends. Any other questions? Cool. Let's do something a little bit more interesting. Oops. Okay. So this is a notebook that I wrote for Strata whenever it was recently. And originally I was like, what borough has the fastest taxi drivers? And I thought it would be funnier if we just called that, which boroughs should we avoid? So first I just define a couple of things. This like P-SQL thing is like, we'll actually like take a SQL Alchemy query, like compile it, stick in the bound parameters, stringify it, and then pass it to SQL parse, which will like format it in a kind of nice way. Otherwise, like SQL Alchemy just kind of spits like a single like solid row of SQL at you, which is hard to like show anyone and make them think it's cool. So I'm going to be using like a bunch of different libraries and even more as the sort of thing goes on. So I have like the New York City taxi trip datasets sitting in a local Postgres instance. And it kind of looks like this, right? It's medallion, hack license, vendor, blah, 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 passenger count, trip time in seconds, and so forth. So the first thing I want to do is actually like get rid of trips that are outside of New York City, because I don't really care about Connecticut or New Jersey or wherever the heck else like taxis can go. I don't think they can go outside the tri-state area. But there are in fact like some points that are just like, you know, in Vermont or whatever. So I sort of went to this this website, and they have a nice little polygon here that outlines New York City for you. And at the bottom, it shows you the minimum, maximum latitude, longitude. So I took those, and I said, I only want trips that are within this box, and I only want trips that are less than the distance, less than or equal to the distance between the corners of the box. So Postgres has some operators like this. I don't even know like what to call this, like left arrow, @ right arrow. But basically what it does is it does like a spherical point-to-point distance between these 2 points. So that's kind of fun. So this is the maximum distance that I want to allow. If there are any trips that are longer than 39 miles, I'm throwing them out. So you can do this with SQL Alchemy, pretty straightforward. And Blaze has this, Blaze sort of like doesn't get in the way. If there's a thing, like for example, like Blaze doesn't have any point data structure or like whatever this operator is. So sometimes you need to get down into the thing that Blaze is talking to, because it doesn't give you like full access to the thing. So we get this out, and now we have our floating point. Then we filter out a bunch of like crappy data. For example, there are trip distances that are negative. There are trip distances that are just like huge, like thousands of miles. There are trip times that are like 0 as well as negative. There are passenger counts that are like 255. There are passenger count, there's also like a significant amount of passenger counts that are like 9. Like, are there taxis that can hold 9 people? Even the van, anyway. So, and then this sort of filter right here is I'm not using the whole polygon, but I'm making a box out of New York City. And so that this is using Blaze, and you can kind of see that it looks like pandas, but this is executing against Postgres. And so this is the SQL query that's actually being run. All right, so there isn't a column that already exists in the table that has like the trip time in hours, because I want to calculate miles per hour. So I'm going to make that. And the way you do that is with a function in Blaze called transform, which I'm going to sort of move down here so you guys can see. Right, so I write the thing, valid is this filter that I have above, and then this filtered data set. I compute a column, I say trip time in seconds, cohorts to a float, and turn it into hours. And then I take valid, the trip distance and divide it by hours to get miles per hour. And then I can kind of just inspect it like that. And this is sending a SQL query in, like slapping like limit 5 on the end, and then bringing back those 5 things. So it'll only bring back as much data as it needs to show the first 10 rows, unless you convert it to something else. And then we can see, for example, like how many trips have an average speed in miles per hour that is like greater than 120 miles per hour. That's pretty fast. So there's like 20,000 trips in there that have, where people are just, I don't know what was going on there, but there's actually some trips in there that have like, that are approaching like 90,000 miles an hour. So there's something strange going on. It's possible that some of the like latitude, longitude, that the distance, or that the speed is taking sort of into account latitude and longitude that have like 0 values in them. because there are those. So I also don't care about trips that are like, moving at a snail's pace. So I'm going to filter those guys out, and then I'm going to project some columns out, right? I'm going to take out the thing that I just computed. I'm going to get the pickup, latitude, longitude, and drop off latitude and longitude. Those are the things I ultimately care about to do my sort of final analysis. So at this point, to figure out like which boroughs I need, which boroughs contain like which data, which taxi trips, I need to like consult an external API because that data is not in the original data set. So I'm going to use Odo and a bunch of other things to get that out. But first, like this is the data that I just created with the filter and the projection, and this is like the sort of SQL query that's being run. So you luckily don't ever have to like look at this stuff unless you want to. So how do we get borough geolocation data? Turns out the city of New York has a pretty nice API that gives you back this XML format called KML that gives you geometries for a particular, for all the boroughs. And it kind of looks like this. Yay, XML. Not. So I'm going to use something even worse than XML. That's called XPath. I'm sure there's some XPath wizards in here. I am not one of them. And so there's place marks are like the nodes in the XML tree that mark the boroughs. So I created some code that no one should ever look at to parse and sort of clean this stuff up. And basically what I'm getting are a string that sort of looks like a CSV file. So it's got the longitude, the latitude, and the borough name. Let's sort of inspect our data with pandas to make sure things like don't look ridiculous. So they don't. And let's like really make sure that things don't look ridiculous. Okay. So this is using bokeh and just wanted to draw the boroughs to make sure that things aren't totally out of control and that the data I'm getting and that what I'm doing with it look sane.
Could you show the code that did that?
Sure.
Just a scatter.
Yeah, so it lets you you pass in a data frame, you give it X and Y that are column names, and then if you give it color, it will cycle through colors and plot the individual groups by a particular color. This code right below it is something that I just discovered like 30 minutes ago because the points were gigantic and sort of filling in the entire borough and looked weird. I'm sure there's a better way to do this, but I don't know bokeh that well. So I was really happy to find that this scatter plot was like really trivial to write once I sort of had my data. All right, so Odo is a thing that will let you turn a thing into another thing. So in this case, I have df as a data frame. I'm turning it into a temporary CSV and then shoving that into a Postgres database. Now you might think, oh, that's like really shitty and inefficient. But the loader is actually generating SQL code specific to the database that uses the native loader for the CSV. So it doesn't like send it to a CSV and then like use pandas, like read CSV, turn it into like, a list of, or, turn it into like a list of dictionaries, send that to the database, which is gonna, have to do its thing writing to the database and so forth, and that's gonna be terribly, terribly slow. This is actually probably the fastest loader in Python. It's sort of cheating though, right? We're like taking the CSV and saying, oh, like what do we know about the CSV? Generate the SQL code for it. But as a user, you're totally insulated for it. So that was really fast, right? That was like 37,000 rows is not a lot of data, but I'm sure if you did that in pandas with like 2SQL, it would probably be 10x slower maybe, I don't know. And for really big things, it's really bad. Like it took like 17 hours to write the entire like New York City taxi trip data set from its CSV into a database. And like 20 minutes if I use Odo. So 20 minutes for 17 hours is pretty good. This is what it looks like, as we sort of know. So now I have to dive down into SQL Alchemy because I want to start using some more primitive geometric objects like boxes, points, and line segments. So what I just sort of did, this bounds right here, this is saying group by the borough and give me the maximum and minimum latitude, longitude. And make a table out of it. Well, it's actually making a select statement, but that doesn't really matter. To work with SQL Alchemy with my Blaze thing, all I have to do is call compute on that, right? And then I make an alias because I'm going to need to join them and I need to keep track of the names. This is sort of the key point that allows me to do what I want to do with this whole thing. And basically what I'm doing is I'm joining on whether a particular trip's line segment was inside of the box of a borough. There's a whole host of problems with doing it this way, but I tried to do it. Postgres has a polygon type, which I tried doing it, but it was much too slow. So I have some ideas about how to get around that, but I couldn't get to them for this talk. Right. So then I'm going to need to select out the things that I want, which are the bounding box name, the borough name, and then all these columns that I had before. Then I'm going to do a group by. I'm going to average the speed per borough and count the number of samples because I want to see if, like, you know, maybe like Queens has a lot fewer cab rides than Manhattan. It does. And finally, this is the final sort of SQL query that all this stuff generates. So I do the filter, then I compute my column that has trip speed, average speed. Then I join that thing with the bounding box, group by, take the average, and get out those columns at the end. And Odo lets you take this whole query that I just built up and just say, boom, turn it into a data frame. This is going to take a little bit. Not that long, maybe like 20 seconds. Yeah.
Would it have been feasible to do all this with just straight pandas? What does the database get you?
So the database gets me the geometric stuff, which I liked because I was able to think about it at a higher level than saying, oh, let me create these filters that are a box rather than just saying hey, Postgres, do your thing. So the end result is this. But not really. It's not that much faster, right? It's 17, and this is not rigorous in any way statistically. So yeah, and of course there's 80. I only have 83 Staten Island cab rides.
But there's really nothing in Staten Island, so they can go fast.
Right. I'm also there. I have a big to-do list here, various things. But okay, so that was the end result. The point is you can kind of Python and Blaze and SQL Alchemy and all these things kind of just let you sort of go hog wild and answer ridiculous questions. Probably useful ones too. So yeah, go ahead.
Pipeline your own sort of user-defined functions. So for example,
That's really hard.
Right now, you couldn't calculate the sort of the polygon bounds.
Yeah.
That's why you're drawing the square based on longitude and latitude. What if I do have a sort of user-defined function in Python that says, allow me to draw the polygon and find what's in the polygon?
Right. So in
Pipe that in.
no, but yeah. So there is PL Python. I've never looked into that, but yeah, it's worth looking into. In that particular example, I actually was doing that about an hour ago, but it was just so dog slow that because you're checking there's 37,000 points versus 4 points for a box. I was also, the way you have to do it is also kind of annoying because the polygon type constructor only accepts a list of strings. So I had to take my latitude, longitude, turn them all into strings, then construct a polygon, then check if the points are, so it was way way less efficient. So that can be, you could probably get around that fairly easy by downsampling the polygon, because it's totally, there's so, like 37,000 points is like totally unnecessary for this analysis, right? I mean, like, maybe it's, you need that for drawing a map, but you don't need that for this thing. So the glaring sort of problem with the box approach is that you have like areas where Brooklyn, Queens, and Manhattan all overlap. So you're going to get wrong answers for whenever a trip is like in, you know, Queens and in Brooklyn. It may say it's like in the same borough. I'm not doing anything more sophisticated with like traffic speeds or dates, like holidays may be more busy. This is also 5% of the entire data set. If I was less, you know, dubious of the Wi-Fi here, I would have used Redshift, and that thing can handle the whole data set in like a talk, in like an amount of time that I could give in a talk. Yeah, so that's it. Any questions? Yeah, I don't know who, I'll just go that way. Go ahead.
Are there any limitations to joining the different data sources?
Meaning, like if I have a database from over here and a thing, right now that stuff only works with in-memory data sets. And it will bring like stuff in memory, do the join, and then give you back essentially a data frame. So you can't, that doesn't work for things that don't fit in memory.
You generally get your aggregations first.
Yeah, you could definitely do that for sure, yeah.
About updates and inserts to the underlying data?
Right, so if I were to run this thing again, it would append to the, there's no updates. We don't have anything that does updates. But that could totally be a thing. That just needs someone to sort of motivate the use case. There's definitely a use case, but.
Once you get a data frame from a select, it's no longer connected. You modify the data frame, that's your copy.
Yeah, once you turn it into a data frame. Yeah, so you could, yeah, you can definitely like convert it to a data frame, and if you wanted to do something else and insert it back in, you can just say Odo this thing to the database. Depending on where that thing is going to and coming from, it's going to be, the performance is going to vary wildly. So yeah.
I'm curious, how hard is it to create a new backend for a different type of data source that's not, say, SQL?
Not SQL? Is that what you said? Okay, yeah. If it's tabular, it's not very difficult. So there's a couple of things that you have to do, like you have to implement an Odo API, which is like 3 functions, and then you have to implement like as many expressions as you want to work, which is, I don't know, there are probably about like 15 to 20 expressions. So yeah. There are some other questions. Hands? Yeah.
What percentage of pandas API is maybe the right question to ask?
I probably can't give you a number, and the second answer is I don't know. Probably not. Because we a couple of things were like, hey, like we don't really like this API of pandas, so we're gonna use something else, or we're gonna use something that's closer to like a declarative syntax that's closer to SQL, like distinct and so forth. It's a little bike shedding, but it's totally a legitimate question because people ask that all the time, and it usually depends on like how much magic the particular pandas API implements. If it's straightforward, like we could probably do it. If it's like group bys that may mutate state on the grouper and also on the thing that they're grouping on, like it's that kind of stuff is pretty much out of scope because everything in Blaze is immutable. Yeah.
So the compute function that you have,
Mm-hmm.
can you talk a little bit about implementation-wise? It's just like an eval underneath the compute.
Right. So compute says, and we can get into details maybe afterward, but basically what it is it walks the expression tree bottom up, evaluating each expression, turning that into a new leaf, and then recursively doing the same thing. until it finally reaches a thing where there's only one thing in scope. Until it finally reaches a state where there's only one thing in scope, and then it returns. That's sort of the very high-level overview. Any other questions? Yeah.
Do anything with query optimization?
In certain backends, we do like column pruning, but we don't do anything like pushdowns or yeah, we don't do a lot of optimization. We could, but yeah, we haven't had time to implement that yet. So, any other questions? Cool. How much time do I have? Do I have more time? I'm not going to talk anymore. I'm just wondering where.
So actually, I have one more question.
Yeah.
If you have the PostGIS extension in Postgres, you can do spatial operations. Are those like data operations here, or?
So you would have to add a few types to datashape. But once you did that, you have to add a few types of datashape and then tell Odo like, hey, here's how to deal with these types. Here's how to like say, what datashape do they turn into, right? So if I don't know, do they have like a polygon? I'm sure they have like some kind of polygon. Yeah, so any of those geometric objects that you wanted would have to be like describable in both directions. So I would need to be able to say, hey, this is a data shape. What does it turn into in PostGIS? And here's a PostGIS thing. How do I describe it in data shape? Once you did that, you'd probably be able to. I mean, there may be other things, but yeah.
So I'm wondering about like the maturity of the ecosystem, because I mean the stuff you just described is a brief mind thing. Like this is stuff we've been trying to grapple internally and build out where we can. So I'm just wondering, what would you say like any cautions about people kind of diving into using this ecosystem, or just getting a sense of how reliable and what are the pitfalls people watch out?
So I personally have worked fairly heavily on the SQL backend, so that's the thing that I know the most, and that thing has seen the most work out of all the backends. So it also has like the most coverage of the API that it uses because it's using SQL Alchemy, and so sort of using SQL Alchemy is super extendable, and so it allows like us to take advantage of whatever they have. And like for example, I started working on a resample expression, and like surprisingly, I was able to get it to work with like SQLite and Postgres via like various things, and it's kind of built in layers where like anyway, like I would say that the SQL backend is fairly reliable, and that the Mongo backend is not something that you should use. Not necessarily because, well, it is kind of collecting dust a bit, but you just shouldn't. It's kind of a corollary of not using Mongo. So
what other backends is there like SQL?
I think we have a graphic somewhere on the. Well, I'm going to use the graphic anyway because I don't remember what they all are. Backends. Okay. Well, that's invisible. Oops, I don't want to turn up the volume. All right, that's not very useful. So I would say SQL, Pandas, PySpark, depending on PySpark. We have the Spark backend. Actually, what it does is it takes your Blaze expression, translates into SQL, and then turns it into a compiled string, and then runs like whatever the Spark context, whatever .SQL thing it does, and that's what we do. So Blaze has this way that lets you sort of pipe to other backends if there's like an easier way to do that. So I would say anything that's using SQL is going to be pretty reliable. Pandas is good. Spark. PyTables and bcalls are kind of bcalls because like there's various issues that we run into with it sometimes, and PyTables because I don't think anyone's using that. I'm not using it, but it could be interesting. So yeah, they're all sort of in various stages of maturity. It kind of depends on what our users are using, and so since we have users that are doing a lot of SQL, that is where a lot of our efforts are focused. Cool. So thanks, guys.